Okay folks, welcome to another episode of Double Award Physics. In this episode we're going to look at the reflection of light. We're going to look at the law of reflection, and we're going to look at how to form an image in a plane mirror. Okay, so from our last event, if I had an object of some description and I shone a series of waves, shone is the wrong word, but if I sent a series of waves towards it, then you had your wavefront diagram like this, and it struck the object, bounced off, and then your waves came out like this. Okay, without a change in wavelength or anything like that, because there's no change in depth or difficulty, and you had a little arrow on this because it's a ray or it's a directional matter, so you create that into an arrow, and that's that. And how you predict how that all works is you draw a little normal at the surface of the object. And remember, your normal is a dotted imaginary line that makes a right angle to the object you hit. It's super important that it's the object you hit. Okay, biggest mistakes are people try and draw right angles to these rays coming in. Irrelevant. Okay, the normal is compared to the object that you strike. Okay, so light's pretty much exactly the same as that, except it's less complicated because you don't have these annoying little waves on it. It's not like water. Okay, light travels as we imagine it, as a ray. Okay, because it's got exceptionally small waves, or you can think of it as a stream of particles. Essentially, it's a beam. It's a straight line that you fire at something and it bounces off. Okay, so this would be a standard ray diagram as to what we would look like. All right. So if you were to take an object and look at reflection, then you have object, incoming ray, an arrow on your incoming ray, or you lose a mark. Right. Now, question could be complete the ray diagram, in which case you would draw normal at right angles to the object, and then you would draw that bounced off. Okay, remembering to put the arrow on. Now this can all be done by eye because there's no requirement for you to have a protractor in the final exam. Okay, so that's pretty close. Okay, where this angle in here is called the angle of incidence. Okay, we usually just shorten that to I, and in here this is our angle of reflection. Okay, reflection. And they are equal to each other. Or at least they should be. This diagram's a bit sketchy, but they should be equal to each other. So the angle of incidence equals the angle of reflection. The angle of incidence is the angle that you measure between the normal and the actual ray. Okay, so loads of people make the mistake of trying to measure this. That is complete crap. The angle of incidence is this angle in here. Okay, and the angle of reflection is the angle from the normal round to the reflection. Okay, don't make the mistake. Okay, this area in here, meaningless, nobody cares. Right, now, on to the next part then. How do you form an image in a plane mirror? In order for your eyes to form an image, you need at least 2 rays of light in order to do it. Okay, so for you to be able to position something properly, you need 2 rays of light. Okay, so let's put a little object, let's put a little triangle here. Okay, now what you really should do is you should take a couple of rays of light from every single point on this triangle. If you try to do that in the exam, you will be there all day. Okay, so let's assume that this is a mirror rather than a flat object. Okay, the reason I know it's a mirror is I'm going to put some hashed lines at the back of it. Okay, universal symbol for a mirror is you have some hashed lines, or the question tells you it's a mirror. One of the two. Okay, so you got those little dashed lines on the side of it. This tells me that this side over here, this is where real stuff exists, and this side over here is the behind the mirror, imaginary Narnia type land. Okay, so what I do, I pick a point on my object. It doesn't really matter where I pick it. Usually you pick the top, and I draw a ray of light to the mirror. Construct a normal, and then I draw my reflected ray out. Okay, just like that. Right, now the smug ones amongst you, I haven't forgotten about my arrows. So there you go, one arrow there, shows the light goes into and strikes the mirror and then bounces off the mirror. Right, so it's going that way. Okay, now that's great, but it doesn't tell me where the image is located. And what I need then is I need a second ray. Okay, so I'm going to draw that in red just so you can see what's going on. So pop a second ray. It doesn't really matter where you put it. I'm going to pop it there. Okay, so just draw a line randomly somewhere to the mirror. Again, draw normal. Angle of incidence is in here. We need to make our angle of reflection roughly the same. Again, if you were using a protractor, it would be exactly the same. Okay, so do around like that maybe, something like that. Okay. Now we'll see how good my guessing is. Now what you do, there are arrows on these already, but so we'll leave it at that. So now what we have to do is we have to take these lines and dot them all the way back, as if they'd come from back here. Okay, so we do a dotted line all the way back. So you take your ruler and you lay it along that ray, and you dot your line all the way back. And then you dot this one all the way back as well. And I am freaking miles out with this one. Okay, so we'll need to readjust some of these angles, and that's fine. Okay, so that angle's maybe just a little bit too big. So bring that down a bit. Yeah, that's a bit better. Okay, small mistakes lead to big errors in the final measurement. Okay, so no small mistakes. There we are. That's not too bad. Okay, now the reason I know that that's the case is because I want it to intersect here. Okay, the intersect point is where your eye believes that the light came from. So if I put your eyeball down here, okay, awesome eyeball. Okay, then the ray of light goes into your eyeball, sort of, and your brain doesn't know that this is a mirror. Your brain hasn't evolved to know what mirrors are. Okay, so when it believes the light came from back here somewhere, so it tracks the light back in straight lines. Oh, this diagram is shocking, but anyway, tracks it back in straight lines and it builds an image of it. Okay, so it believes that the top of your little triangle is over here. Okay, now not only is there light coming from here, but there's light coming from here, 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 here. But it would make this diagram very messy if we were to do them all in. Basically, your brain puts together this image here. Okay, now the properties of this image are: it is virtual. Okay, there's no real light there. Your brain has made that up, so it's not real. It's a virtual image. Okay, it is the same distance behind mirror as object is in front. And now behind and front we mean that this distance here, between the distance between this object and the mirror here, is the same as this distance here. Okay, those two distances are exactly the same. Okay, think about it: when you see yourself in the mirror, when you take a step back, they take a step back. It'd be extremely weird if you took a step back and your reflection had its nose pressed up against where it would be the front of the mirror. Just stupid. Okay, so it's the same distance behind the mirror as in front. The object is upright. Okay, so it's the same way up. And the object is the same size as original. Okay, there's no lenses here. And that's you. That's reflection in a nutshell. Okay, remember that this is anything that's imaginary, anything that your brain has put together, or anything that science has built is done with a dotted line. So your normals are dotted, and your traced back rays are also dotted. All happy? Good job. Well done. I'll see you next time for refraction.